Good afternoon, students. I'm Chandra Parnavitana. I'm your academic coordinator for the subject CVX6345. And do you hear me? Do you hear me? Hello? Can you hear me? Can somebody speak and let me know whether you hear it or not? Okay, good. You can hear me. Okay, right. Now let's talk about the subject first. This was supposed to be taken by Professor Atapattu, but she has asked me to take over the subject CVX6345. I think she has done a day school for you on ecosystems last time, but today onwards I'll be looking after your course and I'll be the academic coordinator for your subject. First, you need to have an understanding about the conduct of the subject. So there will be 3 exams for you: Cat 1, Cat 2, and final exams, and there will be practicals for you, and you will be informed about the practicals, and so you will have to do all these things and get adequate marks according to your eligibility criteria, which is given in the activity diary, right? Now, if you want to be eligible for the final exam, you need to get the adequate amount of marks given in the activity diary, and you have to get eligible for the subject to write the final exam. Then in the final exam, you have to get more than 40 marks. Then you will pass the subject. And I can see only 6 students are there. I believe there must be more students than this. So shall we wait 1 or 2 minutes? Then about communication, I prefer to make a small email group for all of us so that I can directly send emails to all of you. And I'm planning to conduct extra day schools for you. Okay, so to conduct extra day schools for you, is it convenient for you to have day schools during weekdays after, let's say, after 7:38? Hello? Is it convenient for you to have day schools in the weekdays, let's say from Monday to Friday, from 7:30 to 9:30, something like that, 8 to 10 or something like that? Is it convenient? Is that time period convenient for you? Can somebody answer? Shall I ask each one of you? Ajit, can you speak?
Yes, no problem, sir.
Then Koshila? Koshila? Is it okay for you?
8 to 10 is convenient, sir.
Okay, good.
Okay, sir.
Okay, then Madhuranga? Okay. Then Jeevanta? Jivanta, are you there? Okay, he's also okay. Then Shamila.
No problem, sir. I can.
Okay, good. Then Piyumi. Is Piyumi there? Okay, she's also able to participate. So I'll try to arrange some day schools during weekdays from 8 to 9, 10, I know 8 to 10. So we'll have to do some extra classes for you to cover up. Normally we do day schools. Do you know the difference between day schools and regular lectures in conventional universities? The difference is we do summary lectures for day schools, and you are supposed to read this course material and get knowledgeable about the subject and face the exam. So let me know how many of you have got course materials. Everybody has got course materials? One has got the soft copy. Others? So Piyumi, how did you get the soft copy from the faculty course? Okay. So everybody should go to Moodle and get your soft copies. Now I think one has got it from Moodle. Okay. Now I have uploaded the today's lesson and the PowerPoint presentation to the faculty common course, right? Now I will give you the link to that. I don't have access to this because of the present condition of COVID, and only few of our faculty members has access. So you can use this. I will put it in the chat, right? Wait. Now I have sent a link in the chat box, right? Please check that link. So if you go there, you will get the PPT and the lesson 4 or session 4, which I am going to do today. Actually, I cannot complete lesson 4 because it is a large lesson and an important one. We will try to do as much as possible. Okay. Then about last lecture, what did you learn during last day school? Can somebody tell me what did you learn during last day school? Nobody. You haven't studied anything? Huh? Okay. Right. Now, since we have only 6 in the meeting, could you please type your email in the chat and send it to me, your email. So I will make a group and I will communicate for your day schools and everything through email group. Okay. So can you please type your email in the chat and send me now?
Sir, excuse me.
Yes.
පොඩි ප්‍රශ්නයක් තියෙනවා සර්. මේ අපි සර් දැන් මම තාම රෙජිස්ටර් වෙලා නැහැ කෝස් එකට. ඇඩ්‍රොප් එකේදී ගන්න කියලා බැලුවේ. මේ එතකොට සර් අපි CVX65 33 කියලා එකකුත් තියෙනවනේ.
Yes.
එතකොට අපි මම දැන් ලබන අවුරුද්ද තමයි මේ ඩිග්‍රිය කම්ප්ලීට් කරන්න කියලා ඉන්නේ. එතකොට මං ගන්න ඕනේ මේකද මේ කලින් එකද 65යි 33ද?
The thing is, if you take 6533, you will get 5 credits. Okay.
Oh, yes.
But if you take this course, you will have to take this CVX7242 as well, because it is compulsory for you at level 7. So if you follow both of these courses only, you will get this 6533 number of credits. So if you are planning to get graduate next year, I recommend you to take this CVX6533.
Okay, sir.
Because this year it will be offered. I don't think it will be offered next year. When did you register for the degree? When did you start your degree?
2015.
2015. So it is better you take CVX6533 and
Okay, sir.
finish it off next year.
Next year. Yes, sir.
Because if you take this subject, this is for, of course, those who are new will have to take this, because next year this 6533 will not be offered. So in order for you to get the adequate amount of credits, you will have to do CVX7242, which is designed for designs for environmental engineering. So please discuss with department head as well about this matter, right? Don't take my sole opinion. I just tell my opinion. Okay.
Okay, sir. Thank you.
Right. Now I can see I have received one email, 2, 3, 4, 5. I have received 5 emails. 1, 2, 3, 4, 5. Right. So I'll make a email group for this. Okay. Right. Right. Now I'm going to start the lesson, today's lesson. Do you see the slides? Do you see the slides? I believe you can see it. Right. Okay. Now we'll begin the lesson. Now, I don't know how Professor Banduni has introduced you to the lesson, but since hereinafter we are going to talk about water from session 4 onwards, first I will introduce you to the subject. Now, environmental engineering was called sanitary engineering sometimes back in 80s and 70s and way before. The subject is called sanitary engineering, and gradually it was transformed to environmental engineering due to its core relevance to environmental mitigation and protection. Now, the environmental engineering mainly focus on water treatment and wastewater treatment. But now in the discipline of environmental engineering, other aspects also have come. Things like ecosystem analysis, then noise pollution, air pollution, then environmental impact assessments, environmental law, things like that. But still, major component of environmental engineering consists with water and wastewater treatment. Now today we are going to talk about water treatment. Well, you all know that water and its properties an unusual molecule. It is an unusual molecule because of its molecular structure. It has some unusual properties which allow us to survive on planet, which allow us to live as the way we live today. And water condense below 100 degrees, then below 0 degrees it is solidified, and you can see it on this slide. Now, so this is highly helpful for plant and animal to survive. For example, if water has different temperature ranges, today we would have never been evolved into humans. Now, when we talk about the volume, 71% of Earth's surface is covered with water, which is roughly 1387 into 10 to the power 6 cubic kilometers. That much of water is available on planet Earth. So basically it's a water planet. Okay, so you can understand the distribution of water on Earth is shown in this slide. You can see the 97.1% is there in the oceans, then 2.24% is in the glaciers, then 0.61% is in groundwater, 0.016 is in lakes, then 0.001% is in atmosphere, and 0.0001% is in rivers. So you can understand the distribution. So what do you think? What water can we use? Can we use ocean water as we wish? We can't, right? Then the waters in glacier, we rarely use it. Then water in groundwater in deep aquifers, is it possible for us to acquire all the waters in deep aquifers? That is not possible. Some portion of groundwater we extract through tube wells, but not all, right? Then basically, then this, this 0.001% in the atmosphere also we can't condense by ourselves and use. So basically we have waters in the lakes and we have waters in the rivers. So those are the basic water supplies available for humans. So you can understand, even though water is ample in the world, only a fraction of it can be used for human consumption, right? So at the moment, world is facing a water shortage. And if you go to internet and search, what will happen to India, some parts of China, and some Asian countries, to some African countries, to Arab, you will realize that we are living in paradise, right? So some people say we don't have water, that and this we fight, but the amount of water we have, we are not managing it properly in Sri Lanka. If we manage it properly, we cannot have any water issue in Sri Lanka because we have ample amount of water. And it will be the only country which will come out from water shortages in near future. So please remember this in South Asia. So that is why we should keep our independence and separations from other countries. So if we become slaves of some nation, they could take our even water. There are ways to transport water on ocean, and these possibilities are there. So you need to understand these things, right? If you allow others to come here and start water business, and if you allow them to acquire our lands, so they can simply take over our water. Now, when we talk about water cycle, now this picture, I believe you have studied it during your school time as well. At grade 6, 7, you have studied this. This is water cycle. You know how it works. This water cycle is driven by what energy? Who drives this water cycle? Can somebody answer me? Who drives this water cycle? It is the sun, right? It is the solar energy which drives this water cycle. So the water gets evaporated by the heat of the sun, and it get condensed in the upper atmospheres, and it will float with the winds created by the sun, and it will condense and come down, and it will fill our rivers and lakes, and gradually it will flow into ocean again. So this is water cycle. Now the problem with water cycle is that it is extremely essential for our survival, but with the water cycle, not only water circulate, but also the pollutants. So if you put pollutants into water sources, so they could carry by the water cycle around the globe. So India might be polluting their land. So we think that we are not polluting, but adversely that pollution can affect us. On the other hand, if we pollute, our pollution our pollutants can end up in other countries. So if you want to search, you can go to internet and search, and there is a those who enter now, please send your emails to me on chat, because I am going to make a email group. There is a one who just came now, right? Please send your email to me, because I want to add you to the email group. So if you go to Bay of Bengal, there is a particular area fully covered with plastic, floating plastic. It has become a dead zone on the Bay of Bengal. You can search and see. So let's briefly talk about the sources of water pollutants. So there are two types of sources available for water pollutant. Natural water pollutants are there. Then anthropic or anthropogenic water pollutants are there. So the natural ones are produced by natural causes. Gases from the atmosphere like carbon dioxide, oxygen, nitrogen can get mixed in water. So it can create acids in water. Then liquefaction of salts in soil. So this is actually the accumulation of salt on soil, and vice versa. The salt in soil can get dissolved in water, other way around as well. Then organic forms. If you put organic matter to the water, with time it will start decaying, and the rotting things will create a lot of issues in water. It will degrade the water quality. Then the water quality will adversely affect our health. On the other hand, it will affect the environment. It can kill animals. It can kill our fish breeding grounds. It can destroy our vegetation. It can do many damages. It can create many waterborne diseases, non-transmitted diseases, things like that. Then if the suspended solids, what you see here with this water is full of suspended matter. We will learn about suspended matter, settlable matter, floating matter later. So whatever suspended among water molecules with van der Waals forces are harmful. So microorganisms can hide. They can hide behind these particles and live happily. Now, when it comes to anthropogenic causes, you can see 20% of water pollution is caused by industrial production. You can see 20% is caused by industrial production, raw materials, intermediate products, heat transfer, cooling. Norachole is using seawater, right? So when Norachole is using seawater to cool its boilers, heated water is sent back to the ocean. So it can have adverse effects. Similarly, if you go to dye industry is one of the largest polluters in the entire world. So they just use water for dyeing clothes, and the dye mixed water is disposed to the environment without treatment. If they do that, it can harm the living beings and it can harm us as well. Then if you go to any tanning industry, any other industry, they use water for treatment, for cleaning, for various purposes, for production. So that is how this 20% of water pollution is caused by industrial production comes up. Then the next one is discharge of municipal and domestic wastewater, right? If you don't have an idea about wastewater, soon you will have a better idea about wastewater once we study wastewater engineering. Wastewater is the water that comes out after consumption of water for our purposes. Let's say for bathing, let's say for cooking, let's say for washing. We use it for toilet flushing, urination, excretion, cleaning. For so many things we use water. So once water becomes dirty, once it is objectionable for consumption, we call it wastewater. So we will have a detailed lesson on wastewater later. Then you can see the main culprit or the main sector which contributes to water pollution is farming and fishing activities. Because farming, we apply large quantities of pesticides, herbicides, industrial waste, farming wastes to farmlands, and they will wash off and ended up in water bodies. And in the fishing industry, they use water for cleaning and cutting and packing and so for so many things. So it also causes water pollution. Well, if you talk about the geographic origin of water pollutants, so basically there are two types of sources: point sources, non-point sources. The point sources are the ones which are generated at a certain point. Non-point sources are sources which produce pollutants over an extent of land or over extent of line. So we'll discuss about certain examples. Localized industrial discharge. For example, if there is an industrial factory which is producing some wastewater, it will emit its wastewater at one point. Maybe at the backside there might be one pipe coming out, disposing its wastewater to the natural water body. Then when it comes to non-point sources, then application of fertilizers, herbicides, then road runoff, things like that are non-point sources. So they are produced over an extent of land. The type of effluent flow. Now, when something is coming from a certain location, flow, we call it effluent, right? We learn it better when we do it, when we study wastewater engineering later. So this effluent water that is coming from a certain source can be categorized into several categories. Now those categories are given here: white or rainwater, then domestic wastewater, industrial wastewater, black or urban water. This is generally what is coming from rainwater. Atmospheric pollution, then human activity waste, traffic waste, vegetation waste, leaks could be there. The one who has just joined now, I think his name is Pirasantan, right? So you send me your email in the chat, because I have collected emails from the other members, and I'm going to create an email group. So I will be communicating with that for new day schools, additional day schools, etc. Okay. So send me the email. And also I'll appreciate if you can join the class on time, because this disturbs me. If you keep on coming late, I'll have to admit, I'll have to stop the class and I'll have to go back again. Anyway, let's go back. Type of effluent flow. Then we'll talk about domestic wastewater. These are the discharge to municipal sanitary systems, household, commercial and large facilities such as hospitals, cleaning and fecal matter, normally known as black water. We'll discuss these things in detail later. Then industrial wastewater, then black or urban water, quantified per equivalent population. These are the type of effluents which are coming into water body. Well, for you to summarize the water pollution, you can see that the water pollution is mainly caused by 4 causes. Then the first one is fuel and oil discharges. They float and degrade on water. Then domestic agriculture, food industries, right? So they cause deoxygenation. That means the removal of dissolved oxygen from water. Then chemical agricultural products, pesticides, fertilizers, they cause eutrophication. Then heavy metals and industrial waste, they create toxicity in water. So this is the summary in a nutshell in one diagram. Okay. Now we are getting into the lesson actually. It's about water treatment, right? I'll try to run a YouTube video for you. Give me 1 minute, right?
Access to fresh water is one of the largest drivers of.
Now I will run a video from YouTube. So please go through this YouTube video and let me know you can hear it or not, right?
Creating a modern society. But what allows everyone access to seemingly endless supplies of potable water? It depends on where you live. But chances are behind your tap, there's a municipal water treatment plant. There are two main types of water treatment plants: drinking water or wastewater plants. We'll be focusing in on drinking water plants here, but if you'd like to learn about how wastewater is treated, you can watch the video linked in the upper right here. The question still remains, how exactly does one treatment plant take dirty river water or well water and turn it into water that is safe to drink? It involves a lot of processing, using chemicals, filters, and removing all of the toxins and hazards from a given source. The entire process starts with something called coagulation and flocculation. All drinking water has to come from somewhere, usually being freshwater lakes, rivers, wells, or streams. In these water sources, there's going to be some amount of sediment as well as organic materials in the water. These particles of sand, bacteria, dirt, wood, etc., they all have to be removed before the water can be sent out to city residents. To do this, chemicals called coagulants are added to the water. These chemicals, such as aluminum sulfate or ferric chloride, work to help the particles in the water congeal together. Essentially, these chemicals have the opposite charges of suspended solids, like clays or silts. When combined, the charges of the particles are neutralized, allowing for them to stick together. Coagulants are often added to the water right at the inlet of a drinking water plant, where the water then goes into mixing basins called flocculation basins. In these basins, the solution of water and coagulant will slowly be mixed together to form what are called floc particles. After mixing for a set amount of time determined by water quality in the flocculation basins, the water is moved to sedimentation basins. It's in these holding tanks where the water sits for the floc particles to begin settling out at a faster and faster rate, which is the intended goal of this process. By simply adding and mixing these chemicals into the water and letting that water sit, a large portion of the sediment will settle out to the bottom as sludge, which can be taken away to a landfill or holding facility. The floc particles are ultimately removed from the bottom of basins, and the clean water, being the cleanest at the top due to the settling particles, flows over weirs to the next stage in the process. In some plants, engineered
one book a week, but not many people have time for that. I understand. So I created a company with my business partner, Alex, called Mentor Box. We have 65,000 paying customers. We turn books like this into video format. We've got New York Times bestselling authors, Nobel Prize winners, Pulitzer Prize winners teaching their books. Like Warren Buffett says, the more you learn, the more you earn. My favorite saying from him. Give us 7 minutes and we'll change your life. 7 minutes a day. And we do it for less than the price of Netflix. Click the link below, jump in Mentor Box, you can cancel anytime. We have a library of books. You can listen to them in audio or video format. They're not just book summaries, they're the author.
Actually use dissolved air flotation tanks in place of sedimentation basins. In these cases, Air is pumped into the bottom of the tanks, creating a cascade of tiny bubbles. As these bubbles float to the surface, they take flock particles with them, forming a film of flock on the surface of the tanks. Then a sweeper arm pushes the flock into a collection basin where it's taken to a handling facility. In dissolved air flotation tanks, the clean water is taken from the bottom, where the least amount of flock is. When it comes to designing wastewater treatment plants, engineers will vary techniques based on the water source and how they want their final water to taste, feel, or otherwise be treated. The only regulation is the quality of water being pumped to the city, and in most cases, it doesn't matter how plants get the water to that point, which allows civil engineers a lot of creative freedom in the process. After the majority of solids are removed from the water during coagulation and flocculation, followed by sedimentation, the water flows over weirs to the next step, filtration. The water at this point will start looking clear, but there will still be bacteria and very small suspended solids in the mix. The filtration process will seek to remove the remainder of the suspended solids and bacteria to further bring the water up to snuff. Nearly every potable water treatment plant will use a sand filter for this process. Even in plants where engineers may not think it's needed, often sand filters will be added simply for extra measures to ensure clean water at the end. Sand filters are exactly what they sound like, a basin of fine to coarse sand that filters water. It would theoretically be possible to treat drinking water with only sand filters, but that would result in frequently clogged sand filters, resulting in lower efficiency and more cleaning time. These sand filters can be set up in essentially two different ways. Either the water flows from the bottom and exits the top, or the water flows from the top and exits the bottom. Each layout presents its own set of unique problems, but the most common technique is actually for the water to flow from the bottom to the top. Sand filters aren't highly technical. Water just passes through them and particles get caught as they run out of space to flow through. However, while not highly technical, sand filters are highly efficient. Water flowing out of sand filters will need to have a clarity of around less than 0.3 nephelometric turbidity units, or NTU. Try saying that 3 times fast, or whatever local code is used for water clarity. This measurement is essentially just a way to determine the number of particles still remaining in the water, or turbidity. Many treatment plants will also pass water through activated carbon basins, which you can essentially think of as giant Brita filter tanks. Activated carbon particles have hundreds of tiny pores on them that help remove the tiniest of sediment and bacteria. This process isn't wholly necessary, but it helps improve taste and odor, often a desired trait for city residents. At this point, the water should be mostly crystal clear, but there still remains some residual bacteria. That leads us to the next step, disinfection. There are 3 main ways of disinfection in the water treatment process, which can be used individually or in combination with one another, depending upon design. First, chlorine or chloramine treatment. There's ozone treatment, and finally, ultraviolet radiation treatment. In the US, the main method of disinfection is by adding chloramines or chlorine-based compounds. These compounds, such as chlorine dioxide or monochloramine, work to kill microorganisms. One downside to this process, though, is that these chemicals can react with other organic material in the water to create disinfection byproducts. These disinfection byproducts are harmful to human health and have to be prevented or mitigated. This extraneous reaction with other organic material is also why chlorine disinfection must come at the end of the treatment process. If added at the beginning, an abundance of disinfection byproducts would be created, causing a plethora of issues for the engineers and plant operators. Even with all of this, chlorine is used mainly because of how it kills pathogens. It not only kills any pathogens in the water at the plant, but residual chlorine levels also remain in the tap water, killing any contaminants that might get introduced after leaving the plant. Most cities or states will have maximum or minimum chlorine levels in the treated water in order to keep both the water treated and city residents safe. The other most common method of treatment is ultraviolet radiation. In this process, UV light is shined through the water, which scrambles any bacteria's DNA. This doesn't kill the bacteria, but it makes it impossible for them to reproduce, thus making them harmless. The main downside to this disinfection process is that it isn't residual like the chlorine, meaning that any bacteria introduced to the water after this process can't be treated. Finally, we're left with ozone treatment. This process involves adding ozone, O3, to the water, called ozonation. The ozone kills the bacteria in the water as well as improving the taste and odor. In most cases, this treatment process also requires that a chemical be used to remove any ozone at the end, such as sodium bisulfate, as not to cause any harmful effects to the city's population or anyone who might drink the water. After the water is treated in any one of these 3 disinfection processes, it's ready to be pumped into the city's pipe network for delivery to your tap. The water flowing out of a plant is tested for various levels of chemicals, particles, and other qualities all outlined in a plant's permit. This permit, set by the governing agency, regulates water quality and holds the treatment plant accountable in the treatment process. At this point, all the water is fit for human consumption per the permit, and the treatment plant is tasked with keeping it flowing through the pipes in your city. Constant pressures of 40 psi must be kept at the outlets of the water in the system so that in areas of high elevation in the pipe network, the water retains residual pressure. 1 foot in water elevation is directly correlated to an increase or decrease of 0.433 psi. So as water is pumped throughout the city, its pressure at any given point of differing elevation fluctuates. Positive pressure always has to be achieved as to not let any external water in the ground flow through pipe cracks or joints. This would contaminate the entire system and is one reason why you might experience a boil water notice. Essentially, that means engineers have reason to believe that somewhere in that city's pipe network dropped below the required PSI and water or contaminants might have infiltrated the system. Massive pumps at the treatment plant supply pressure to the system through constant operation. Some of this pressure can be stored as elevation in water towers, which can give pumps a backup in emergencies or fire flows. In a lot of cases, water towers allow the pumps at the treatment plant to run at a constant rate, which increases efficiency and removes downtime problems. This combination of pumps and water towers allows your tap to remain flowing and otherwise allows you to live in the comfort of your own home. Civil engineers and treatment plant operators work around the clock to provide clean water through water treatment plants. At this point, we've taken a look at the most common potable water treatment techniques, but there are tens to hundreds of other deviations we haven't discussed. This draws back to one of the coolest things about water treatment plant design. You're able to use any number of creative solutions to clean the water, and as long as it comes out clean, you've done your job well. Don't forget about the thankless job of being a water treatment plant operator, though. These men and women work around the clock to keep treatment plants running 24/7 so you can always have fresh water. A lot of time, money, and effort goes into making sure that you can have that nice glass of water on demand.
Okay, that introduces you to the subject. Okay. Well, you can understand that there are many processes involved in water treatment. We are going to study one by one, right? Let's go back to the presentation. Now, I have extracted this from your note, so the lesson. Now, you can download it from the link that I have given in Faculty Common Course. You can just go there and you will be directed to the location where the PowerPoint presentations and the lessons are uploaded, right? So, to provide water free from visible suspended matter, of course, will you like to consume water with suspended matter in it? Let's say small dust particles. Let's say some timber particles. If you have, you need to have a good feeling to drink water or consume water, right? So you won't like to consume. Let's say this. I brought a glass of water for me to drink during lecture. Now this one, I feel like drinking it because it is clean and it tastes good. So it's a human thing, it's a emotional thing, right? So So it should be free of this visible matter, right? Then it should not have a bad color or a bad taste or a odor. If you smell it, it should feel good. Then that is why when I live in Kandy, normally the water quality here is very good. When I travel to Jaffna, Vaunia, I always carry a fair amount of water with me because drinking makes me difficult, right, to work over there. I have worked in those areas, let's say about 2-3 years. I used to carry a lot of water from home. Then objectionable dissolved matter. Let's say if you have organic matter and bacteria here, right? They are objectionable for our health. So you need to have to remove objectionable dissolved matter. Then bacteria indicative of pollution. Now, if you have bacteria here, of course you cannot see it through your naked eye, but of course you will have to put it under a microscope. If you put it under a microscope, you will realize how many bacteria live in this water. So it should free of bacteria. Then aggressive constituents. What are aggressive constituents? I think you know that in Sri Lanka, we are having 75 to 80 cases of cancer patients every day. We are discovering new cancer patients. So this is a very high rate for a population of us. So this is because of aggressive constituents, things like heavy metals and other stuff. So it should be free of these aggressive constituents. Now, ways and means of measuring pollutants. Now, of course, if you want to measure your weight, there has to be a unit. If you want to measure your height, there must be a unit. Sorry, things like that. So there must be a way to measure the pollutants in the water. So the way of measuring pollutants in the water is by water quality parameters. We call them water quality parameters, and those are listed here. We will study them later in detail. Physical and chemical parameters, right? Solids, we can measure solids, color, odor, taste, we can measure. Then biochemical oxygen demand, that which represents organic matter in the water. Then total organic carbon is also represents organic matter. Then oil and grease, acidity, conductivity. Acidity, the conductivity is the ability to conduct electricity. It's a measure of the presence of ions in water, right? So there are limits for these parameters. Chloride, chlorine, hypochlorate, sulfate, sulfides, ammonia, ammonium, nitrate, nitrite, they are all toxic if it is present in excess quantities, and we will be shortly learning about those excess quantities. Then things like temperature, if you have very high temperature, you may not be able to consume it. It can damage the environment, things like that. Then if you have low dissolved oxygen, it is bad for taste and health. If you have high dissolved oxygen also, it is bad because it will become corrosive. Then chemical oxygen demand, which gives you the total amount of matter present in the water. Then oxidability, the phenols, alkalinity, hardness. You know why Jaffna water is difficult to drink is because of its hardness. Even if you go to Anuradhapura, water is hard, right? So this hardness has some implications. Then radiological parameters, then biological parameters, especially when it comes to biological parameters, we are talking about bacteria and harmful bacteria. We call them fecal coliforms, things like that. So the physical characteristics which influence the water are these things, right? Now I have clearly extracted this from your note. Can you just read it for 1 minute, please? 1 minute. I think you have gone through it. Temperature, it says important for its effect on other properties such as speeding up chemical reactions, changing solubility of gases, amplifying taste and odor. So there has to be a certain level of temperature to achieve these things. Then the taste and odor, due to dissolved organic in nature, impurities often cause this problem. For example, phenols and difficult to measure. Now, this taste and odor is a human thing, and it is a relative thing. One person might say it is tasty, one person might say it is not tasty. So you need to concentrate on this taste and odor. The next one is color. Then true color due to material in solution. Then apparent color due to suspended matter. Now there are two types of colors. Then true color is the color which is given to a certain substance by its material. But apparent color is the color which is given by its suspended matter. For example, if you dissolve certain substances in water, say here, now if you dissolve something here, and if it is suspended among water particles, you might not see it's the true color of water, right? Color of water is colorless, but sometimes we give a color to water. But if matters are suspended here, it won't have the real color. The natural yellow color in upland catchment water is due to organic acids and it's harmless. Now, if you look at Mahavali or some other river in upper catchments, it looks yellowish. This is due to organic acids and sometimes it is due to the presence of certain type of bacteria and algae. But they are generally harmless. There is a unit called Hazen, measured in degrees Hazen. So color is measured using Hazen meters. Then there is a parameter called turbidity. So can you read this slide as well for 1 minute? Okay. Now turbidity is colloidal solids give water a cloudy appearance, right? Now turbidity, we say this water is turbid if you can't see the other side properly, right? So there is a measure. This is called NTU, and we will be studying about this in sedimentation design, sedimentation chamber design, and coagulation and sedimentation part. Then electrical conductivity depends on the quantity of dissolved salts. So if you have sodium hydroxide, sodium chloride, then magnesium hydroxide, magnesium chloride, magnesium sulfate, things like that here. So this water becomes electrically conductive. If you put current will travel very well. So it will increase the conductivity. Anyway, because of the presence of protons, this will work as a conductor. But the presence of salt will increase its electrical conductivity. Then it comes to major one, solids. So there are three types of solids. You can see three words here, right? Right now this one. TDS, total dissolved solids. The matter which is dissolved in water. Then there is something called it is suspended solid. So are discrete particles which may filtered out, right? So dissolved solids are among water molecules, and we will further study about these dissolved solids in sedimentation. They are among the water molecules. So they are very difficult. They are very fine particles, very difficult to filter it out. But suspended matter are the ones that are suspended in the water with the attractions and floating and buoyancy effect. And those can be filtered out. Then there is one type called settleable solids. These things can be settled easily with the grid chambers because those can be removed using gravity. So there is a test called Imhoff-Kohn. We use it to do this, and you can read it later. Then when it comes to chemical characteristics of water, there is pH. Of course, you know what is pH. It is the percentage of hydrogen. And then alkalinity is the opposite of the alkalinity. We call it water is alkaline. Is the pH value is above 7, right? Due to the presence of bicarbonate, carbonate, and hydroxide, it is useful as it provides buffering to resist changes in pH, right? Then acidity. Acidity is the opposite of alkalinity, right? When the pH value is below 7, we say it acidic. So if it is too acidic, it is harmful for us, right? So for acidity, there are different ranges. You can read it out from the note, right? Then hardness, the property which prevents leather formation with soap. Right? It produces scale in hot water systems due to metallic ions of calcium, magnesium, iron, and selenium. Right? These are serious issues in Sri Lanka. So if you go to certain parts in our country, hardness is a serious problem. So the chemical characteristics continue. Can you read it for half a minute? So it's about dissolved oxygen. So if the dissolved oxygen is not there in water, we may not have good quality biological life, then of course we may not have good taste in water. So therefore, the presence of dissolved oxygen in water is very essential. Then the nitrogen is present in 4 different forms. You will be studying about nitrification, denitrification process later. The chloride gives a brackish taste and may be indicator of sewage pollution due to the chloride content of urine. Now, when you urinate, urine contains fair high amount of chloride. So if the natural water is high with chloride, it means that there is a sewage pollution of that water. Now we were talking about parameters, the way of measuring the water quality. But to really measure the thing, we need to have certain standards. For example, if the standard is here, if the parameter goes above the standards, that means that water is not good. So these standards are established by SLS, right? Now here you can see, you can read it. In Sri Lanka, it has been declared by authority for Sri Lanka standards as SLS 614 2013. There was an earlier version as well. This is the latest one, 2013 guideline. The limits declared for each water quality parameter is the maximum permissible limit. So that means whatever these parameters are, they should be below these limits, right? If it is above these limits, that water is objectionable for consumption, right? Let's see, we'll enlarge this portion and see. Now you can see, for example, I'll take, let's say, pH. pH has to be between 6.5 to 8.5. That is the range for drinking water. Okay, right? Then if you go to nitrate, nitrate has to be below 50 milligrams a liter of ppm. So these standards are established. Okay, so there are so many parameters, you can read it by yourself, right? Then when it comes to biological things, here you can see the total coliforms. We will be talking about these things in disinfection. There, the limits are declared here. Okay. Then, in order to design a treatment plant, first you need to know the quality of the source. Then you need to know how much water is required to be treated. So for that, you need to forecast the water demand. So in order to design, you can read it, in order to design a water treatment facility, we should predict the future demand for water caused by population growth. You can see if the population goes up, then the demand for water will also goes up. So you need to predict that. There are two models to predict the future demands, namely linear model and exponential model. We normally adapt to this exponential model, and these things are there in your book, right? Now I have taken this from a water board guideline for designs. Now you can see, first you need to get some statistics from census and statistics, and you have to plot it, and you have to predict it for coming years using this equation here. Pn equals P into 1 plus R to the power N. This R stands for growth rate at the projection time, right? Growth rate. Then N is the number of years that you are planning to project. P is the base population. Let's say if you are doing it from today's statistics, today's population, let's say 2.3 million. If it is 2.3 million, you have to use that. If it is 100,000, you have to use that. Okay. Then the steps in determining the water demand. Now to do this exercise, you have to do it systematically. If you don't work systematically in design, you will be messed up with your work, right? Now, first step is to select a per capita water demand for domestic use. So what is this per capita? Per capita is per person, per year. right? Per capita is per person, right? So if you click this, now this table is also there in your note. Now per capita water demand varies according to your lifestyle. You can see for medium and rural, it is around 120. Let's say for 1,000 to 1,500 consumers. Large rural, 1,500 to 5,000. Normally it's around 140 liters per capita per day. Small urban, 185. Medium urban, 185. Large urban, if the population is about 20,000, we consider it as a large urban design. If you are designing for a population about 20,000, needed to be separately assessed. You need to do a proper assessment, right, to make an estimation, right? Now, next step is to determine the institutional demand. What are institutional demands? What is open university? Is it a manufacturing plant or a manufacturing industry or a institution? It's a institution, right? And you can see for different institutions, there are ways to calculate demand. For example, hospitals. For hospitals, now it is calculated as 220 to 300 per bed per day. You can see per bed we calculate. Let's say if you have a hospital of 500 beds, so you have to take a value and multiply it by 500. Let's say for hostels, if you are designing for a hostel, we have to consider value for a bed and calculate. Then boarding school per resident. Of course, you have to calculate it per person basis. Then for restaurants, it is per seat. Let's say if you have a restaurant of 90 seats, then you have to multiply it by the number of seats. Then bus and railway station, then per user. Day schools, yeah, offices, factories, cinemas, all these things are there with the appropriate unit, right? So you have to use your common sense and calculate it, right? Industrial demand. Yes, I can see one person has switched on his mic. Is there a question? No. Okay. Now the industrial demand, right? The industrial demand you need to calculate with the industrial parameters. So once everything is calculated, as you can see, in this slide, to calculate the total demand, you just have to add it up, right? And after getting the total demand, you have to add on top of that something called non-revenue water. So what is this non-revenue water? Normally it is around 35 to 45 in SL. For new plants, it is around 10 to 15%. We'll see what is this NRW is. Now NRW or non-revenue water, we call it, is the loss of water without billing, right? Let's say you have a water meter at your house, right? So when water is sent to you, if the water is lost between the plant and your house on the plumbing, it will not be billed to anyone, right? Only the taxpayers will pay money for production of water, but nobody will believe, right? So this is called non-revenue water, where the leakage is taking place after your water meter are not considered as non-revenue water. Why? Because it is revenue for the government, because you are paid for that, because it has come through your meter and your bill will be prepared based on your meter reading. So it is revenued water, but we are talking about non-revenue water. These are the leakages and losses in the distribution system. And you can see here, right? You can see here. This is in Europe. You can see the distribution of non-revenue water. So you can see some less developed countries has more losses in water, right? Typical to Sri Lanka, right? Now, after adding that, this 1 to 10 to 15%, then estimate the treatment plant losses. Now, treatment plant capacity has to be decided with these steps, right? First, you have to calculate the total demand, then you have to add up the NRW, then you have to add the treatment plant losses to estimate the amount of water that you need to extract from the source. Now, let's say the source can be a river, source can be a what? Lake, it could be groundwater, right? It could be some sort of water, fresh water source. But you need to estimate it, right? To design the plant, you can use this. But to determine the extraction from the source, you need to add another 7.5 to 10% of total output. So you are going to deliver a total output with the NRW, but on top of NRW addition, you have to add another 7.5 to 10% for extraction. This is how we calculate the thing, right? Now we are moving into water treatment plant. Now you can see. Now this diagram I have extracted from your book. Now we take water from a water source, we screen it, then we send it through several steps in order to produce fresh water for consumption. Now this process consists with several steps as you were shown during the video as well. So first you have to do screening, then aeration, coagulation, mixing and flocculation, sedimentation, filtration, disinfection, storage, and disinfection. So these things you have to do in a typical treatment plant, right? Now today I'll be discussing about screening. Then after that, other things I will schedule a new day school, and which I will let you know through emails, and I will also put that in a faculty common course and let you know, right? Now screen. Now once you are getting water from, once you have started getting water from the source, the water that is coming might be full of debris and suspended matter. So this floating and suspended matter mostly can be removed using screens. So there are two types of screens. One type is called score screens. So can you just go through this for 1 minute, this slide? Okay, right. So for rivers and lake intakes, some form of protective boom or core screen about 75 millimeter opening. Now this opening is roughly 75 millimeters opening should be used to prevent large floating objects entering the intake, right? So if the large objects go to the treatment plant, it might damage your pumps and other substances, elements. So you have to prevent that. The velocity of water through the screen opening should not exceed 0.5 meters per second. If it is coming at a very high velocity, it could damage your plant. So you need to protect it. So to design, these are the parameters. Approach velocity has to be 0.5 meters per second. Bar spacing 50 to 100 millimeters. Bar thickness about 15 millimeters. The maximum allowable head loss in the system is 150 millimeters. Then the depth of the bar is 0.7 to 1. Angle of slope is theta from vertical. Now this shows a cross section of this channel. The cross section of this channel, right? Please follow this carefully. The cross section, let's say the cross section of this channel. The longitudinal section is shown here, right? Now this line represents the bar screen, which is at an angle of theta to the vertical, right? The flow is approaching and you need to calculate the required area of the screen, right? Now, if this is AC, the cross-sectional area here, right? AC, what is the area of AS? AS equal to sec theta, right? I'll show you. Now, this is the slope theta. So this AS equals AC sec theta. Then void space, there is something called VSR, void space ratio. Now, even though the screen is here, the flow will not go through the entire screen. It will only go through the void. So you need to calculate the void space ratio here. Normally it is calculated with the space and space plus thickness of this bar here, right? Space and space plus thickness, space divided by space plus thickness. So net area of flow, A net is the area, actually effective area where the flow will go through here, because the flow cannot go through bars, it will only flow through caps, right? So the net area of flow, A net equals AS into VSR. Then the velocity through the screen, when the velocity goes through the screen, it becomes flow divided by A net, right? Flow divided by A net. Let's say approach velocity VA, the head loss through screen should be VB squared minus VA squared over 2G into, this is from hydraulics. I'm quite sure you have studied hydraulics right now. So this is 0.7 is a factor. When water goes through an orifice, there are certain losses, and this is how it is being calculated. Now this H value, VB is the approach velocity, sorry, VA is the approach velocity, VB is the bar velocity. So you can calculate the head loss through this subject, through the screen. So it has to be less than 150 millimeters. So this is the design limitation. If it is less than 150 millimeters, this is accepted. Now we will move into fine screen. I'll not do a fine screen design. I think it should be done in 7242. So you can read it for 1 minute. Oh, you go back. Now, this kind of a screen is called a fine screen, right? So basically the spacing is much more smaller. So after post screening, we do fine screening to remove fine particles. Normally we don't do a fine screen design at this stage, but you will be taught, I believe you will be taught of a fine screen design in CVX6245. That's all for today. So we will stop the day school today. If you have not dropped the email to me yet, please drop it, because I am planning to uh, uh, send you everything through email, right? And a lot of communications I'll do through email. At the moment, there are 6 students. Uh, so I'll appreciate your participation. Thank you very much. If you have questions, you can ask.
Yes, sir.
Yes.
මාත් ලබන අවුරුද්දේ මගේ කෝස් එක ඉවර කරන්න ප්ලෑන් කරේ. මේ අර ගයිඩ් බුක් එකේ 65 45 කියන එකක් මේ සැරේ තිබෙන තියෙන තමයි 63 45 කියන එක ගත්තේ මම. ඒතකොට සර් මොකද කරන්නේ?
ගයිඩ් බුක් එකේ 65 33 තිබ්බේ නැද්ද?
මේක තමයි සර් උපකරේ.
Okay, then you can shift to that 65 33 if you like. If you like, you can do this, but again I believe you will have to now the thing is you need to get the adequate amount of credits to get the degree.
Yes.
Okay. I think it is compulsory for you to take the level 7 subject as well. That is CVX6245. Can you just talk to the department head and ask about this? Normally you need to get the, if you do this subject, you will have to do the other subject as well, because you are new, right? Because you want to graduate. If you want to graduate, how many subjects are there for you to graduate?
7 subject.
7 subjects are there, eh? So do you think you can graduate next year?
Yes.
Then can you talk to the department head and ask about this matter?
Okay. Thank you.
Right. Now one says now Koshila, now things are, you just go through the chat. Now I have sent you a link. This is where everything has been uploaded. Please go to this link and see whether it is there. Anyway, I'll be putting things to you. I'll be giving this a recording of this session in my YouTube channel, right? And I'll upload it to my YouTube channel and I'll send you the link so that you can see. And I will send you the details through emails as well. Okay. And always refer to this faculty course. And it will also give you a lot of notices about practicals, various things which will be coming up, right? So please be vigilant, right? Okay then. Okay then. Thank you very much for participation, right?
Thank you, sir.